Okay, hello everyone. Today's topic is calculus and we will be starting with integral calculus. So first of all, we will be seeing some basic standard integrals that we all know, and here are these formulas. So first of all, these are some indefinite integral formulas, and we should be thoroughly able to recall these when we are doing questions. So first of all, we would be seeing this in a minute. Okay, so this is a basic formula. Second one is a integration of constant, that is kx plus c. 1 by x is log x. A to the power x is a to the power x upon log base a. Cos x is sin x. Similarly, we see this. Okay, here is the integration of cosec x, that is minus log cosec x plus cot x, which can also be written and reduced as log of tan x by 2 plus c. So these are some of the basic formulas that we have learned in 10th and 11th class, and here are also some of the basic integration, definite integration formulas. Just have a look at them once, because we will be using them very much rigorously in in our further question solving. Okay, let us move to the next slide. Here there are some formulas I have used some formulas of definite integration that deals with the quadratic equation. So these first three are for are the formulas when we are having 1 by quadratic form of an definite integration. So 1 by x square plus a square dx integration is 1 by a tan inverse x by a plus c. Integration of 1 by x square minus a square is 1 by 2a log x minus a upon x plus a. 1 by a square minus x square dx is 1 by 2a log a plus x a minus x. Similarly, we see these three other formulas when we have 1 by root quadratic. So these three should you should have learned these three in your 11th class, or like you can learn these now, because these would be you can make a sheet of these formulas, because these would be we would be using these very rigorously in our further question solving. Okay, so here we have three more formulas for root quadratic form. So you should learn these like this: 1 by quadratic, 1 by root quadratic, and here these are the formulas for root quadratic. Okay, now here we have 1 by linear into root of quadratic. This this formula is also derived like this: 1 by a sec inverse x by a plus c. You can go into the derivation of these formulas. The derivation comes out to be very simple. Suppose we are required to derive this formula. So the basic derivation for this formula can be done by substitution. Here we can substitute x by a sine theta, or like yes, or a. Here we will like substitute x by a sine theta, or we can also substitute it by a tan theta. So depending upon our use case, we can substitute this and we can derive this formula. But in JEE mains, we will be required to solve the questions in a fast-paced way. So uh, I will be I will be supposing that you will learn these formulas before JEE mains. So this would be beneficial for you, because at that time you cannot sit there and derive derive this whole big integration by using substitution. It would take up 10 to 15 minutes of yours, and eventually you will end up wasting a lot of time. Okay, so let us move to the next slide. In case, please see this: e to the power ax sine bx dx. Here here we have this e here we have this integration as e to the power ax upon a square plus b square. Similarly, please also see this formula. Okay, let's move to the next slide. Now I have used some examples in the next slide, and these can be done from reducing them into from converting them into the formulas that we have learned in the previous slide. So suppose we have an integration of a to the power x e to the power x. This can be combined and written as a e to the power x dx. Further, we know integration of a to the power x dx is a to the power x upon log a plus c. So in place of a, we directly have here a into e. So we will be replacing a ae as a constant in place of a. So what we got, ae to the power x upon log e plus c. This is written like this. Okay, let's move to the next question. Next question says evaluate sine inverse cos x dx. So first of all, what we need is we need a simple expression here. We directly do not have an expression to integrate sine inverse cos x function like this. So what we will do is we will use inverse trigonometric concepts here, and we will write cos x as sine pi by 2 minus x. Okay, sine inverse sine theta. What is sine inverse sine theta? Sine inverse sine theta is theta. So sine inverse sine of pi by 2 minus x is pi by 2 minus x dx. Now we have come to a simple integration pi by 2 minus x dx. Would be for this we can simply write the integration as pi by 2 minus x whole square upon minus 2 plus c. This can also be done by separating the integrals over pi by 2 and minus x. Like suppose here the integration has been done like here the integration is done by taking this as a unique uh, by supposing this as a variable. What we have done here is we have supposed this pi by 2 minus x as a variable y. So what I have done here is what is the integration of y? Integration of y is y square. Okay, y square by 2, and since it is minus x, so when we substitute pi by 2 minus x by y, here we get a minus dy. So here we have got a negative sign. So this is basically y square by 2 with a negative sign plus the constant of integration. And we again substitute y by pi by 2 minus x, but this can also be simply done by pi by 2 and x separate integration. Okay, these are some simple integration. Let us move to some more basic complex integrations. Okay, so now in the first 5 minutes we have seen the revision of our 11th class, that how integration questions comes and how we would be solving them. Now let us see some methods of integration and comparison between differentiation and integration. So the operation of differentiation and integration are defined on functions. Yes, obviously true, we know this. The derivative of a function, when it exists in a unique function where the integral of a function is not unique. In fact, there are infinitely many integrals of functions so that any two integrals differ by a constant. Yes, it is true. What the second point is trying to say is that the derivative of a function exists uniquely. Suppose we have a function sin x. Its derivative is cos x. There is no other derivative for sin x other than cos x. So cos x is a unique derivative of sin x. But let's suppose we have a function x. So its integration, so the integration of x would be x square by 2 plus c. Here this c can be here this c can take infinitely many values. So the integral of a function can be infinitely many terms. Okay, can be infinitely many functions. So this is the point it is trying to say. Let us move to the next point. The derivative of function at a point, if exists, is meaningful, but integral of a function at point does not have any sense. Yes, because at some point, basically integration is area under a function. So if we are trying to, if we are trying to make, if we are trying to make a sense that integration at a unique point on a graph, so it will not make any sense because integration is defined over a interval. So basically, at a point, there is no sense of saying integration. Yeah, these are some basic uh, basic theories of integration. We all know. Every function is not differentiable. Similarly, every function is not integrable. Very much true. The derivative of function at a point determines the slope of the tangent. Yes, we know derivative is the slope. The integral of a function represent a family of curves having parallel tangents at the point of intersection of the curves of the family with the lines orthogonal to the axis representing the variable of integration. Okay, what it is trying to say is the integration of a function is basically representing a family of curves. Okay, and that family of curves having parallel tangents at the point of intersection of the curves of the family with the lines orthogonal to the axis representing the variable of integration. Okay, basically suppose there are two functions that intersect each other. So at for those two functions, the integration represents the family of curves which are parallel tangents at the point of integration, at the point of intersection of the two curves. Okay, so these are some of the theories. The process of differentiation and integration are inverse of each other. Very much true. The operation of differentiation and integration are operational functions. Okay, this is the basic rule of splitting integration, which we already saw in this example number 5. And the constant can be taken out here. This point we saw here in example number 5. So I suppose it is clear. Okay, the constant can be taken out side the differential as well as the integral sign. See, d by dx k f of x. So always the constant can be taken out of differentiation as well as from integration. Okay, differentiation and integration both are processes involving limits. Okay, basically, generally we do not apply limits in differentiation, but in integration we are required to apply. Uh, it involve limits. Okay, when we are talking of definite integration, differentiation also has limits, but it is only used when we are talking of slope. When we are talking of calculating finite slope. Okay. Now let us see method of integrations. Integration by substitution, integration by parts, integration using partial fractions, and reduced formulas. So we will see these all one by one. Okay. What is meant by integration by substitution? So here is the list of integrals of the form ax plus b. So let us see them one by one. Okay, you do not have to remember all these 15 formulas. There would be I will be telling you just one little trick, and it would be used in all these formulas. So what the trick or the method says is when you are when you are integrating anything of the form f of ax plus b dx. So what it says is you just treat this as a normal variable. You just suppose here is y, or you just supposed there is only x present here, and integrate it, and in place of x you are assuming, just write ax plus b. What additionally you will have to do is you will have to divide the whole thing by a. Okay, you will be dividing this whole thing by a. What is a here? What will be a here? The coefficient of x. So whenever you get a linear function inside a function, that is, in place of x you are given a linear function. So here you would be just normally doing the integration, and at the end you will replace, at the end you will divide your answer by the coefficient of x. So we can see these, you can see this in these 15 to 14 formulas. Here it is ax plus b to the power n. So we will write 1 by a. We have divided it, and normally we have written ax plus b to the power n plus 1 upon n plus 1, as generally we do. Here also we have done the same thing. Please take a look at all of these. Okay, now let us move forward. These were all the basic integration formulas that we have seen in the first slide. What we have just done is, in all these formulas, we have divided the answer by a, and we have replaced x by ax plus b. So this was the basic thing. It just seems that there are too many formulas to learn. Okay, now see, we have these two questions. Here what it is written is 8x plus 13 divided by root 4x plus 7. So how we would be doing this type of integration? So what we will be trying to do is, we will try to make this term, we will we directly here directly we do not know the formula of linear upon root of linear. So we will try to convert this above linear equation in the form of this given below linear equation. So yes, what we will do, 8x, for 8x plus 13 we will add 1 and subtract 1. So we get 8x plus 14 minus 1. This can be written as 2 times of 4x plus 7 minus 1. 2 can come outside. Root of 4x plus 7 dx minus integration of 1 by root 4x plus 7 dx. Now for 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 anything like this, root of, now this is like root of x dx, and here we have, here in place of x we have 4x plus 7. So by the, so what we have learned in the previous slide, what we will do it do what we will do is, we will treat this thing as x, and just we will substitute it. What we will do is, just we will put this thing in place of x, and we will perform the integration normally, and at the end, for this integration we will divide the answer of this integration by 4, that is the coefficient of x. So 4x plus 7 to the power 3 by 2 divided by 4 into 3 by 2. And for this 1 by root of linear, this is something like 1 by root x, which is very easy. That is x to the power minus half, that becomes root x minus root x. So what here we will be doing is we have 4x plus 7 to the power half divided by minus half. It is equal. It is like the normal integration, and in place of x we will be writing 4x plus 7, that is this term, and also we will be dividing over here. So this becomes too much easy. This was integration by substitution. When we substitute a linear substitute x by a linear function in x. Okay, let us move forward. This is also a simple example. It is an example like this. What we will do here is we will multiply here by 2, and then we will multiply and divide by 2. Then we will convert this plus 2 as minus 1 plus 3. So this can be done similarly. Okay, integration of the form root of f of x n f dash x dx. So what is happening here? Let us see. Now suppose we substitute this. Here what we do is we substitute it. Suppose we substitute f of x with y, and when we are substituting f of x with y, we get y to the power n, and since y is equal to f of x, dy would be f dash x dx, and we have this f dash x dx term present here. So we will write here dy. So finally we get integration of y to the power n dy. Okay, if it seems good, then we know the integration of y to the power n dy is y to the power n plus 1 upon n plus 1. So here we will take some questions simultaneously with the theory we have covered. So like, we will develop better understanding with the pace of the theory. Okay. So and after doing all this, we will replace y with f of x. So finally we get f of x to the power n plus 1 upon n plus 1. And obviously n cannot be minus 1 when we are doing these cases. Okay. There is a specific case where n comes to be minus 1. Suppose if something is like f dash x dx upon f of x. So there in place of this we get log of, here we get, if n is equal to minus 1, so in place of this we directly get log mod fx plus c. Okay, now let us see some questions regarding this. So here we have log x to the power 3 1 by x dx. So we know the differentiation of log x is 1 by x. So by using this formula, uh, here they are substituting it with t log x is equal to 2 and 1 by x dx is equal to dt. So here they do this integration as follows, and we can directly use this formula, or we can also substitute it like the way I have taught you. Second question says 4 sine inverse x whole cube divided by root of 1 minus x square. So the first and foremost thing is you should learn all these forms. You should make a cheat sheet, and you should make a short notes where you have written all the forms of integration. The first form of integration was this integration of f8 ax plus b dx. Second form is fx to the power n f dash x when we have the differentiation of the function present along with the function. Okay, let us move to the third form. These were the basic questions we have seen. Sin inverse x differentiation was 1 by root of 1 minus x square, and we would substitute sin inverse x with t and 1 by root 1 minus x square dx with dt. Okay, simple. If you are confusing how we get this term, how can how I am so easily converting dt with dx and the root of 1 minus x square. So what you just have to do is you have written this equation sin inverse x is equal to t. Differentiate both the sides. You will get 1 by root 1 minus x square dx, and for t you will get dt. So in this way you can easily get this. Here you have here you got the final answer as sin inverse x to the power 4 plus c. Okay. And this is also a similar question. Here it is 2 to the power 2 to the power to the power k, 2 to the power 2 to the power k, 2 to the power k. And here what we can do is we will substitute this bigger power with t, and these two, this complete thing is the differentiation of the this single term. These three things are the differentiation of this single function. So this can also be done in the same way. Let's move to the next form. Okay, the third form says integration of root of fx f dash x dx. So it is moreover basically the same thing. They have substituted n by minus half. So we have seen this type of form. So we will not be giving more time to this. Let us see integration of the form. Now let us see the next form. The next form says integration of sine to the power mx dx, cos to the power mx, cos to the power cos x to the power m dx. So let us see how we would be doing this. Now to evaluate this type of integrals, if m is less than 4, we express sine x to the power m and cos x to the power m in terms of sines and cosines of multiples of x by using trigonometric identities. Okay, suppose we have got this ms2, so we will use this identity. Sin square x is 1 minus cos 2x by 2. For cos square x, we use this. For sin cube x, we will be using this identity, because for sin cube x we do not directly have an integration, and also for cos cube x we directly do not have an integration. But for sin 3x and 3 sin x we have learned the integration. So this is a form. So let us first complete the five different types of form of integration. Would be seeing the questions. Suppose here, like again, we have got this sine cube x dx. So we convert it by 3 sin x minus sin 3x by 4 dx, and this is easily integrable like this. So let us go to the next form. Now suppose you have got this form cos to the power 4x. So generally in JEE you directly do not get sine to the power 10x. You will get lesser powers. Suppose you got sine to the power. Suppose you have got sine to the power 6x. So in that case, what you would be doing is, in that case, I will suggest you will suppose you have got sine to the power 6x. So in that case, you will reduce them to a power of form like you have this sine term inside, and you have a power less than equal to 4 uh, at the for sin x. Suppose sin x to the power 6, sin x to the power 6 can be converted as sin x to the power 3 whole to the power 2. So first of all, we will write the substitution for sin x to the power 3. Then we will square it, and then we will again write the substitution of sin x to the power 2. So in this way we can do this. Similarly, like what they have done for cos x to the power 4. For cos x to the power 4, they have used cos x square. They have used cos x square to the power 2. So here you can clearly see what they have written. Okay, they have opened the square here. They have like taken the constant out. These are simple integration. For cos square 2x, they have again substituted with 1 plus cos 4x by 2. So when you get powers of m greater than equal to, here this what this form was, sin x to the power m or cos x to the power m. When you get powers of m greater than 4, at that time you may require to substitute two times. Take here what we have done. Here we have substituted it once, and here we have used the substituted uh, second second time for the second time. Okay, so we substitute these power terms using trigonometric identities. So you should be able to do these. So this came the final answer. Then this becomes a very basic integration. This is easily solvable. Let us let us take a look to the next form. Next form says integrals of the form sin mx cos nx dx sin nx dx. Here we have the multiples of sines and cos. But when they are, we have this multiples together. So we use the following trigonometric identities. What we do is we simply convert this sin a cos b cos a sin b cos a cos b sin a sin b and in the summation form, because in summation form we we read that when we have a summation in integration, then the integration can be distributed over summation, so that becomes very easy. So sin a cos b would be converted like sin a plus b plus sin a minus b, and 2 cos a sin b would be converted to sin a plus b minus sin a minus b. Generally, we will not have this two factor. So what we would be doing is we will divide this two uh, in this summation part. So here let us take a quick look to this question number 17. What is sin 3x cos 4x dx? Integration of sin 3x cos 4x dx. So we are continuously taking a look to the question so that we get to know this form. Till now we have covered five forms, and let us see let us see this question. This is integration of sin 3x cos 4x dx. So what we have done here, we have multiplied by 2 and we have divided by 2, and this becomes 1 by 2 sin 7x, this sin minus x dx. So it was sin a cos b. Sin a cos b is sin a plus b plus sin a minus b. Sin a plus b, 3x plus 4x becomes 7x. Sin a minus b, 3x minus 4x becomes sin minus x. So for these, the integration becomes this thing. So it was a simple question. Okay. Now, first of all, let us take a look at some more forms of integration. Then we would be seeing questions, and then questions are available. So you can take a look at the questions. So the sixth form says integrals of the form sin x m cos x n dx, where m and n are natural numbers. So Here, there, we have to follow some steps to reduce it to get the integration of this. So, what the step says? Obtain the integral this. So check the exponents of sin x and cos x. First of all, we will be checking what are the exponents. So if the exponent of sin x is an odd positive integer, put cos x is equal to 2. If the exponent of cos x is an odd positive integer, if n is odd, put sin x is equal to 2. Whichever power is odd, we will keep the base, we will keep the opposite base as t. Suppose if m is odd, we will put cos x is equal to t. If n is odd, we would put sin x is equal to t. Okay, so if exponents of sin x and cos x both are odd, put either sin x or cos x. If both of these are odd, you can put any one of sin x or cos x as t. So why we are doing this, we would be substituting any one of the trigonometric function by t, and then we will substitute dx by the then we will substitute dx by the differentiation of that. Suppose here if n was odd, so we would put sin x is equal to t. We will get dt is equal to cos x dx. we'll take a we will take a cos x from out from here, and we will substitute it by dt, and the leftover cos x can be converted into the form of 1 minus sine square x, root of 1 minus sine square x to the power n minus 1. And further it can be further it can the sine square x can be written as root of 1 minus t square. uh, we will see this seems a little bit complex when you hear this, but if you will see this formula, you will understand that it is very easy. You just have to remember this. If the power is odd for cos x, then we will replace sin x by t, and vice versa for the power of sin x. Okay. Now, what the other case, if the exponents of sin x and cos x both are even positive, both are even positive integers, then the expression in terms of by using, okay, what it says is if both are even positive integers, then expression sin x to the power m cos x to the power n in terms of sines and cosines of multiples of x by using trigonometric results, or de Moivre's theorem. Okay, so this de Moivre's theorem is directly not in our GE course, so let us skip this part. What the second thing say, 4 point says is evaluate the integral operating in step 3. Okay, so we have covered the basic questions that would be coming in RJ. So let us take a quick look at this example. This is sine cube x cos to the power 4x dx. Now the power this m is equal to 3. The, the power of sine x is on. So just tell me what we would be converting with t. What would we would be replacing t with? So we would replace cos x with t. So we will write cos x is equal to t. So here we will get cos x is equal to t and differentiated both the sides. So we get minus sin x dx is equal to dt in this way. So you can see we can replace dx by minus dt sin x, minus dt by sin x. So we will replace it by minus dt by sin x, and cos x is represented replaced by t. So we get a t to the power 4. So the sin x gets cancelled. We get minus comes outside, minus sin square x t to the power 4 dt. What we do is here we put sin square x as 1 minus cos square x, and 1 minus cos square x can be written as 1 minus t square. So this basically, then we will multiply this t to the power 4 and 1 minus t square, and finally we get the simple linear equations with exponential powers, and we can finally integrate them in this way, and at the end we'll substitute t again by cos x. So this is our final answer. This was the basic trick for this form of integration. So now we have learned seven form of integration. Let us take a look to the next form. Okay, eighth form, some special integration. So whenever you see an expression like this, a square plus x square, what you have to do is replace x with a tan theta. Whenever you see a square minus x square, see, for this I told you in the start of the lecture, then you can derive all those integration that you have learned by using these substitutions. But actually you do not need to when you can learn these. So also sometimes, like, there comes a complex integration. So just have a look at these, and just remember, whenever you get a square minus x square, you will have to replace it by x is equal to a sine theta or a cos theta. For x square minus a square, replace it by x is equal to a sec theta or x is equal to a cos a cosec theta. So, and whenever you get this type of linears, the linear which is not convertible into two summation root of a minus x upon a plus x, root of a plus x upon a minus x. So for this, replace x by a cos 2 theta. Suppose you get this type of linear by linear or linear into linear under the root. So replace x by a cos square theta plus beta sine square theta. So these type of questions do not come much, do not come much in J mains, but you should just know these. How do you have to do? You will have to basically learn the type of forms. Okay. First of all, let us take a look at the forms. Let's complete some forms and then just restore questions. Now we have this form, integration of rational and irrational function. Suppose we have this form as 1 by quadratic. So this can be reduced as a, a square, uh, quadratic scan 1 by quadratic. So this can be reduced as in the form of 1 by x square minus a square, or 1 by x square plus a square, or 1 by a square minus x square, depending upon what the quadratic is. So suppose we have got a quadratic 1 by 2x square plus x minus 2. First of all, we will take the 2 out, and we got x square plus x by 2 minus half. So this is basically x square plus 2 times of x into 1 by 4. So this is basically, here we will add 1 by 4 and we will subtract 1 by 4 whole square. So you get this. After evaluating this, we get minus 3 by 4 whole square. And here we have got this x plus 1 by 4 whole square minus 3 by 4 whole square. And for this function 1 by x square minus a square, we have learned the integration, that this integration is log of x minus a upon x plus a. Now let us move to the next form. So this we will have to practice these questions to know uh, how to convert these quadratics in a quadratic of the form x square minus a square, or x square plus a square, or a square minus x square. So this we can do easily. Whenever you will get a quadratic with the coefficient of x square as a negative coefficient, so at that time we will be converting the quadratic into 1 by a square minus x square, a square minus x square. So basically, this here the coefficient was positive, so we converted it as x square minus, in the form of x square minus a square. Basically, I am trying to say here, this is taken as a capital X, or this is assumed as y. Okay, but this is x plus 1 by 4. Please do not write directly x here. That would be a blunder. Okay. Now we have this 1 by root quadratic. So here it is the coefficient of x square is negative, as I said. So we will be converting it in the form of 1 by root of a square minus x square. So we have converted it like this. So this was all about this. This was all about the 1 by quadratic form. Now we have this linear upon quadratic. So here are these steps written. We do not need to read these steps. What you can basically just do is just convert this quadratic in the form as I told you in the previous form. Then convert the linear in the form of the quadratic by by what we have done previously, by like unitary multiplying by 2, by multiplying by any constant, or by dividing by any constant, or playing with addition and subtraction. Let us take a quick look at this example and you will get to learn what that previous form was saying. So suppose here we have this x square plus x plus 1. So what we can do is, first of all we can convert this as, okay, so first of all we can convert this denominator in a quadratic of the form y square minus a square, or like in the form of x square plus a square in another form. But here we have also one more way to solve this. Substitute this x by lambda, and then substitute this d by dx x square plus mu, and what we get finally is, substitute this above linear term by lambda times differentiation of the denominator plus mu, lambda f dash plus f dash x plus u. So you will have to learn this type of learn this form. So definite integration is more about learning the forms and then applying these. So this was the ninth or tenth form. So what we generally do is we substitute the above linear by lambda f dash x plus mu times. So we have seen this example. We will get this two summation, and after getting these two summations we can apply basically we will have this form, which is f dash x upon fx dx. So this is the second form, if you remember, that we have learned in the forms, and this is the this is from the this variations, you will find the value of lambda and mu, and you will split this integration in these two forms. Okay, so these were the 10 basic forms that we saw here. Now let me see if we can see some more basic forms, or uh, okay. Let us complete this 5.2 part. 5.2.4, which is the 13th form. What does this say is linear upon root quadratic. So here what we would be doing is we would be substituting this linear by lambda d by dx of this quadratic plus mu. So we have done this. We are doing the same basic thing. So it is not much of a it is not much of an hard to do task. So whenever you are getting linear by quadratic, what you have to do is you will have to substitute linear by lambda d by dx of quadratic plus mu. And by comparisons, you can find the value of lambda and mu. Let us take a quick look at this example. So you substitute this 2x plus 3 by lambda. Differentiation of this would be 2x plus 4 plus mu. Now by comparisons, you can find the value of lambda comparing the coefficient of power of x. So here the coefficient of x is 2 and here the coefficient of x is 2 lambda. 2 lambda is equal to 2, lambda comes 1 and 4 lambda plus mu is equal to 3. So lambda was 1, mu comes out to be minus 1. Now we directly put this as 2x plus 4 upon root x plus 4x plus 1 dx minus 1 upon root 4x root x square plus 4x plus 1. So in this way we have done this example. You just have to learn this. You just have to learn this type of this thing, and you will be able to do multiple questions. What the other form say is px is a polynomial of degree greater than or equal to 2. Then what we would be doing? Then we will first of all convert it in a um, qx plus rx by ax square plus bx plus c, where qx is a function. It may be linear function, and rx is a linear function upon quadratic again. Qx can also be a constant like it is in this example. These are the last two examples we would be taking in this class. Let us take a quick look. See, we have this x square plus 5x plus 3 divided by x square plus 3x plus 2. So first of all, we will make this above numerator in this form of denominator, and we make it like x square plus 3x plus 2 plus 1. So we get 1 plus 2x plus 1 upon 1 plus 2x plus 1 upon x square plus 3x plus 2. And this can be done by integration form number 13. So this was integration form number 15. So these 15 forms that we have discussed in this class with some examples need to be remembered. These are the type of examples that comes in the JEE questions, and when you thoroughly revise these forms, then you can do these examples or do these questions very easily. Okay, thank you.